Remember paper maps? Folding them was an art form. Getting lost was part of the adventure. Today we have GPS, it's on our phones, it's in our cars. We use it without a second thought. But this technology has a fascinating history. It all started with a satellite called Sputnik. Imagine this, it's 1957. The Cold War is raging. The Soviet Union launches Sputnik, the first artificial satellite. This event shocked the world. It also sparked a technological revolution. Little did we know Sputnik would pave the way for GPS. This is the story of that journey, from a beeping satellite to the pinpoint accuracy we have today. Sputnik wasn't just a metal sphere orbiting Earth, it was a wake-up call. The Soviets were ahead in the space race. The US needed to catch up, and fast. But Sputnik also offered an unexpected opportunity. Scientists at MIT, listening to Sputnik's signal, noticed something interesting. The frequency of the signal changed as the satellite moved towards and away from them. This was the Doppler effect in action. Think of an ambulance siren. As it approaches, the siren sounds higher-pitched. As it moves away, the pitch drops. This is because the sound waves are compressed or stretched by the movement. The same thing happens with light and radio waves. Scientists realized they could use this effect to track satellites. By measuring the change in frequency, they could calculate a satellite's position and speed. This was a crucial step towards satellite navigation. The US Navy took the lead in developing a satellite navigation system. Their goal? To accurately track submarines, especially those carrying nuclear missiles. This led to the creation of Transit, the world's first satellite navigation system. Launched in 1960, Transit used the Doppler effect to provide location data. Imagine you're on a submarine submerged for days. You need to know your location to launch a missile accurately. Transit provided this information. It wasn't perfect. It took hours to get a single location fix. And it only worked in one dimension, telling you your latitude and longitude, but not your altitude. Still, Transit was a major breakthrough. It proved that satellite navigation was possible. It paved the way for a more sophisticated system, GPS. Enter Dr. Ivan Getting, a brilliant physicist. In the early 1960s, the US Air Force approached him. They wanted a system to guide their missiles with pinpoint accuracy. Getting, working on a project called 621B, proposed a revolutionary idea. He envisioned a constellation of satellites orbiting Earth in precise patterns. These satellites would transmit signals. Receivers on the ground could use these signals to calculate their position in 3 dimensions: latitude, longitude, and altitude. Imagine a giant net in space cast by these satellites. This net would cover the entire globe, providing location data to anyone with a receiver. Getting's vision was ambitious. It required overcoming significant technical challenges, but it laid the foundation for GPS as we know it today. His concept of a satellite constellation would become the backbone of GPS. Section 5. Atomic clocks, keeping time from space, because every nanosecond counts. Accuracy was key for GPS. To pinpoint a location on Earth, the timing of the signals from the satellites had to be incredibly precise. Even a tiny error in timing could throw off the location calculations by miles. The solution? Atomic clocks. These incredibly accurate timekeepers use the vibrations of atoms to measure time. They're so precise that they lose less than a second every million years. Think of it this way, if an atomic clock were set at the beginning of the universe, it would only be off by a few seconds today. Each GPS satellite carries multiple atomic clocks. These clocks ensure that the signals are timed perfectly. This level of precision is what allows GPS to provide such accurate location data. Section 6. Parkinson's persistence. Navstar, the dawn of GPS as we know it. Bradford Parkinson, an Air Force colonel, is considered the father of GPS. He took Dr. Getting's concept and turned it into reality. Parkinson led the team that developed the navigation system with timing and ranging, Navstar, which we now know as GPS. Imagine the challenges. Parkinson had to manage a massive project, coordinate with numerous agencies, and overcome technical hurdles. But he persevered. Under his leadership, the first Navstar satellite was launched in 1978. More satellites followed, forming the GPS constellation we rely on today. Parkinson's dedication and leadership were crucial in making GPS a reality. Section 7. From battlefield to backroads, GPS opens up to the world. Initially, GPS was a military tool. It helped guide missiles, troops, and ships. But its potential for civilian use was undeniable. In the 1980s, the US government made a decision. They would make GPS accessible to the public. This decision revolutionized navigation. GPS receivers, once bulky and expensive, became smaller, cheaper, and more widely available. Imagine the possibilities. Hikers could navigate remote trails, drivers could find their way in unfamiliar cities, pilots could fly with greater precision. The applications were endless. This decision to open up GPS transformed our world. Section 8. A universe of uses. GPS is everywhere. Today, GPS is everywhere. It's in our phones, cars, planes, and even our watches. But its reach extends far beyond navigation. GPS plays a crucial role in transportation, tracking trucks, ships, and planes, optimizing routes and improving efficiency, emergency services, helping first responders locate people in need quickly and accurately, agriculture, guiding tractors for precision farming, reducing waste and increasing yields, finance, synchronizing financial transactions across the globe, ensuring accuracy and security, science, tracking earthquakes, monitoring weather patterns, and studying climate change. And let's not forget about those ride-sharing apps and food delivery services we rely on. GPS makes it all possible, connecting us in ways we never thought imaginable. Section 9. GPS, a modern marvel with economic and societal impact. GPS has had a profound impact on our world. Economically, it has created new industries, it has boosted productivity, it has made businesses more efficient. Socially, GPS has made our lives easier. It helps us stay connected. It keeps us safe. It allows us to explore our world with confidence. Imagine a world without GPS. It's hard to fathom. Our world is intricately connected to this technology. From the products we buy to the way we communicate, GPS plays a role. Section 10. Conclusion. The future of GPS, beyond navigation and into the unknown. From a beeping satellite in the Cold War to an indispensable part of our daily lives, GPS has come a long way. But the journey isn't over. As technology advances, so too will GPS. We can expect even greater accuracy, new applications, and a deeper integration into our world. Imagine self-driving cars navigating our roads, guided by a super-precise GPS network. Imagine drones delivering packages with pinpoint accuracy. Imagine exploring new frontiers both on Earth and in space with GPS as our guide. The future of GPS is bright, filled with possibilities that will continue to shape our world in remarkable ways. We hope you've enjoyed a brief story of GPS. Hit that like button, share, and subscribe. See you next time.